Hi guys, so this first video for this week is on graphing inequality rules. And on Monday in class, we discovered some of these rules through our activity. So this is a recap of that, and then we're going to actually practice graphing them ourselves. So let's recap from our activity what we got. So this is a less than symbol. This is less or equal. Then we have our greater and our greater or equal. All right, so line type is similar to circle type. Actually, it isn't similar to, it's exactly the same. So for example, a less than symbol does not have the word equal in it, so I can't include it. So that means my line is going to be open just like my circle. And an open line means it looks like that. It's a dashed line or dotted. You can call it many things. When it does say equal, it is going to be a closed line or solid like this. All right, so same thing for greater. If it says just greater, it is going to be an open or dashed line. And as soon as it says that word equal to, then I'm changing it to solid or closed, just like our circle types. Okay, so shading direction, also similar to how we did it on a number line, except now we're doing it on a graph. So when the graph is diagonal, it changes the direction to be up or down, but just think of them as smaller numbers. Think of up as bigger numbers and down as smaller, because not every graph is going to be up or down. Most of them will be. So that's why we're going to use that language. But in case you ever get a graph that isn't like that, you want to make sure that you know that it still means up bigger numbers, down smaller numbers. Okay, so for less than, we are going to shade in the downward direction. Or smaller numbers. So for example, if I had this as my line, I would shade down. Less than or equal to, it's also less, so it's still going to remain down. The only difference there is our line type. Greater changes my direction because now we're talking about bigger numbers, and bigger numbers are up. So I would shade above. And greater than or equal to is still up, still bigger numbers. The only difference is that solid line. All right, so there's just a recap on our rules. Very similar to our number line rules. So don't think of it as like this whole new thing to memorize. Okay, so let's actually try graphing this. All right, so some of the questions we want to ask ourselves when we're doing this is, first, is it in y equals mx plus b form? Now, I'm not going to say equals anymore because we have an inequality, but remember this is called slope-intercept form. They're still linear, so I'm still looking for that format because it does represent a straight line. So if it is, I can go ahead and graph. Now, with slope-intercept form, in order to graph, we want to identify what is our slope. All right, so our slope is always next to the m. So in this case, our slope is 3. And there's no number on the bottom, so I'm going to make it 3/1 to help me plot. What is our y-intercept? Our y-intercept is next to, the y-intercept is the b, the number by itself. So in this case, it is -2. Okay, so I'm going to start there and plot those points before I continue asking myself those questions. So my y-intercept is -2, so that starts on my y-axis. And then my slope tells me that it's going to rise 3, and it's going to move to the right 1 space. Now, if I don't know those rules, I can actually go ahead and plug this into my calculator and just get a table. But in my calculator, I would have to do the equals. And we just have to know later on that it's not equal to, and we need to keep that in mind when we're plotting it, but we can still get the table of values. So in your calculator, you would still get -1, -5, 0, -2, 1, 1, 2, 4, okay, and so on. So you could do it either way. All right, so now that we've done that, I'm going to go to step number 4, or question number 4. Is the line going to be solid or dashed? So now I look at my symbol. All right, my symbol here is less than. Okay, so less than means it is not equal to, so my line is going to be open or dashed. So when I connect it, I literally have to connect it using an open line. All right, now for less than, am I going to shade up or down? Less than means smaller, so I'm going to shade down. If you're never sure which one is up or down, this is what I like to think. I like to pick a point. And I like to think if I look up here or down here, which one is my smaller numbers? Because I want to shade less. My smaller numbers on my y-axis are going this way. So that's how I'm going to shade it in. I need to shade the entire side. I want to think of this as like a coloring book. Wherever the line splits is where I'm going to shade. So I can go ahead and erase that arrow. All right. Now the last part is we're going to label our solution set. Our solution is where the shaded region is. So this whole region is a solution. So if I wanted to name a coordinate in my solution, I can name it anywhere in that shaded spot. The one thing we want to keep in mind is when it's not equal to, just like the number line, when it's not equal to on the number line, were we allowed to include the number that was here? Let's say this number was 4. Were we allowed to include this 4? No, because it wasn't included. Same thing for this line. When we have a open line like we do here, all right, we cannot include that in our solution, but we can include anything in the shaded region. So when in doubt, pick something in the shading. That is going to be your secure bet. So I'm going to pick this coordinate. It's random. That coordinate is 8, 3, so that is considered a solution. Why don't you go ahead and name another solution? Good. So if you have any questions, make sure to enter them at the end of this video. See you tomorrow.